Now that we've done our facing operations by bringing the whole block down to 1.8 inches thick, we're ready to start contouring around the outside to get the actual tic-tac-toe block down to the right width and length. So we're now going to be taking that end mill and we're going to be running it full depth right around the outside here. Multiple passes to do that. We need to make sure that the end mill we're using has enough flutes to get this full depth if we're going to do it that way. The one that I'm holding does not, but the one that we'll program will have enough flutes that it'll have full cut all the way to the outside. This one could only really cut this far deep. Because we're doing a full depth cut, in our last video or two, we talked about the maximum depth of cut to be 100 thousandths or 0.1. We're going to break that rule, but we're going to do it because we're only going to take a little bit each pass coming in, a little bit at a time. We're not going to take real heavy passes this direction here. It might be full depth, but it's going to be a small in that direction. So there are some ways that we can get around those general rules that we set here for our program, and that's one of them, is by taking a little bit at a time. So looking at where we are, if we're going to start in, we're going to go to the top view again. Anytime we start a new tool path, we want to make sure we're in the top view. We're going to go Tool Paths, Contour. 2D or 3D, we're going to stay 2D. We're just going to grab this edge right here, and it should automatically, it did not, see it grab this little fillet. I'm going to do other face. It's not grabbing it. Okay, let's try, no, tool path, contour, let's grab that edge. Nope. Okay, so if that doesn't work, there are other ways to grab that edge. We're going to actually rotate just a little bit so we can get down to the bottom. Toolpath, contour, 3D. We're going to grab that edge way down at the bottom. It does not matter depth-wise where we grab our contour, because when we get to linking parameters in the windows, we can tell it how deep we're going to cut anyway. So as long as we can get the profile that we want, it's going to work. So, okay. And now we're into our window with all the settings. So, tool, we're going to be using a 3/4 inch end mill. So select library tool, filter, and we're going to go to end mills right there. Okay. We have lots of them to choose from. Here's the 3/4 inch, 0.75. You might not be able to see your diameters very well. If you expand this little window right here, you can see diameters a lot nicer, which helps you find them. I mean, you can read them too, but helps you find what you're looking for. This does happen to say that this particular one, in the simulation purposes, has a flute length of, I don't know if it's saying 2 inches or if that's overall length, but it does have some general settings in here. Again, it doesn't really matter for the purposes of MasterCam as long as we load the right tool in the CNC. So 3/4 inch. For tool number, in the CNC, this is going to be tool number 8. The face mill was 9. So 8, 8, and 8. You do need to change, especially the length offset and tool number. They need to match. I always change the diameter offset right away too. So those should all be set to 8, those 3. 3/4 inch end mill. All right, for spindle speed. So if we pull out our notes from the last video, we have RPM is equal to cutting speed times 4 divided by the diameter of the bit. So 400 cutting speed times 4 divided by 0.75, 3/4 of an inch, gives us RPM of around 2 grand. And I said in carbide it typically double that, so I'm going to just round it to 4,000. So for spindle speed, 4,000. All right, for feed rate, coming to this one, RPM times number of teeth times the chip load. So RPM is going to be 4,000 times 4 teeth, times our, and we'll go 5 thou again, chip load. So we bring over our calculator. 4,000 times 4 teeth times a chip load of 5 thou. Is going to be a feed rate of 80. Now, normally I would punch in the 80, but as we mentioned, we're going to be taking a full depth pass here. That bit's going to be all the way down in there, taking that full flute length. It can probably handle it, no problem, in plastic, being a carbide end mill. But just for safety's sake, I'm going to slow that down a little bit. So instead of 80, we're going to type in 50. Gives us a chip load of around 3 thou instead of the 5 thou we calculated. Plunge rate, we're not plunging into the material, so it doesn't really matter. 50 again, rapid retract to come out quick. So that would be the settings that we have there. You'll notice our tool still says 294 from when we loaded, even though we told it 8. But as soon as we click out and go back in, it'll now say tool 8. 3/4 inch end mill. Okay. Cut parameters. Holder, we're not doing anything in. We're always leaving holder. So cut parameters. We're just going to leave this alone too. We're going to come all the way into the walls. We're going to let the computer do the offsets, so that'll be fine. Depth cuts, we need to turn them on. Right now they're off. I lied. We're going to leave that off because we're going all the way down to our final depth. Otherwise, it'd be taking steps to get down there. So we're going to leave depth cuts off. Lead in, lead out, we'll leave it at what it's at. Eventually, if we want to play with how far it leads in or out to save on time, we can mess with these two numbers right here. And then these two simultaneously for the out. But we'll just leave it for now. Breakthrough would be as if we're going through the part deeper, which we're not, so we're going to leave that off. Alright, this is the one we're going to mess with, multipass. We're going to take little bits at a time. So multipass, and we want to take, let's go with 50 thousandths, 0.05 per pass, and we're going to take 5 passes. And we'll get to see what that looks like in simulation. But we can see over here that it's taking multiple passes into the final size, X. Multipass is X and Y direction, horizontally, where depth cuts is going to be Z direction. All right, we do not need, oh, we want a finishing pass. 1, and our finishing passes, as we mentioned before, are always 8 thou. So that'll be the nice, clean wall edge when we're done. So finishing pass, we'll make sure that this wall is nice and clean, hopefully smooth for us when the part is done by taking a nice small finishing pass. Alright, I always do finishing passes at the final depth. I always choose keep tool down, just saves time in machining. And there's nothing really in the way to hit in what we're doing. So there's our multipass window. Okay, we're going to leave tabs alone. Linking parameters, our rule, always absolute, absolute, absolute. Everything on the left line lined up. Depth, we're going all the way down to here, way down there. So it should be negative 1.75 to get all the way down. Top of stock, we're still going to say is way up here at 0. And then these numbers just need to be above top of stock, which they are. And we're good. And you see it created a bunch of passes. Here's our lead in and lead out. Pretty big radius and distance, but it works. And it's coming in 5 passes plus a finishing pass. So green, green, pretty simulate. Rotate a little bit and go. There's our 3 facing passes, 2, 3, 4, 5, and our finishing pass for contouring. All right, let's go play that one more time. Okay, so let's go look at the back plot version. I'm going to go front view again. I'm going to go Alt S for shade. Green, green, back plot, this button. Make sure my tooling is on and hit play. I can speed it up a little bit if I want to get to my next ops. And there, we're going to slow it down. So here is that end mill. And we can see it's off the part right here, coming around the backside. You'll see it's off the part over here, making one of its multi-passes, but it's all the way down to Z, 1.75 deep. That's one of the reasons I really like watching backplot, is because we can really see what it's doing. It's getting closer, almost there, and I'm going to slow it down because now it's going to come in to that final pass and hit this wall over here. And there, it's right on the wall. So there is the contour of our part. We've now done 2 operations in MasterCam, facing and contouring, and hopefully all of your windows match the parameters that we've been going through here. Tooling, cut, multipass, and linking are the 4 windows that really matter on this particular operation for contouring.